In this video, I am going to verify that sine squared x minus tangent x over cosine squared x minus cotangent x is equal to tangent squared x. The first step is to change everything to sines and cosines. Tangent x is equivalent to sine x over cosine x, so we can replace that. Cotangent x is equivalent to cosine x over sine x, so we can replace that as well. There are two fractions in this problem, and we need everything to be in fractions. So we can put sine squared x over 1 and cosine squared x over 1. Remember, this doesn't change the value, just the form. Now this is a complex fraction, with fractions being subtracted in the numerator as well as the denominator. In order to simplify complex fractions, we have to find the common denominator of all four fractions and multiply each individual fraction by it. The denominators are 1, cosine x, 1, and sine x. The common denominator is sine x times cosine x. I found that by multiplying the denominators. Now we have to multiply each individual fraction by sine x times cosine x. This is what it will look like. Each of the fractions is being multiplied by sine x times cosine x. Let's look at the first fraction. The denominator is 1, and it does not cancel out with any of the terms from the numerator, so we simply multiply across. Sine x times sine squared x is sine cubed x. Cosine is simply being multiplied, and 1 times 1 is 1, so we don't need that one. In the next term, sine x over cosine x is in the denominator, while cosine x is in the numerator, so these two cancel each other out, and we are left with sine x times sine x. Sine x times sine x is sine squared x. In this term, 1 is in the denominator, and it does not cancel out with anything in the numerator, so we simply multiply across. Cosine x times cosine squared x is cosine cubed x. Sine is just being multiplied, and 1 times 1 is 1, so this 1 goes away. The last term is cosine x over sine x. Sine x is in the denominator, and sine x is in the numerator, so these two cancel out. And you are left with cosine x times cosine x. Cosine x times cosine x is cosine squared x. As you can see, we have gotten rid of all the fractions, and we can continue solving. Let's look at the numerator. Cosine x times sine cubed x minus sine squared x. We can see that we can factor out a sine squared x because both terms contain it. When you factor out sine squared x, it goes on the outside, and 1 takes its place. When you factor out sine squared x out of sine cubed x, it becomes sine x, and cosine x remains. Let's look at the denominator. Sine x times cosine cubed x minus cosine squared x. We can see that we can factor out cosine squared x since both terms contain it. When you factor out a cosine squared x, it goes on the outside, and 1 takes its place. When you factor out cosine squared x out of cosine cubed x, you're left with cosine x. Remember that when you factor out, you have to have parentheses as well. there's a fraction part between these two terms. In the parentheses, the numerator is exactly the same as the denominator. Therefore, this is all equal to 1. So we can remove it. We are left with sine squared x over cosine squared x. If you match up sine squared x and cosine squared x, you can notice that the shape of tangent squared x is exactly the same. These two colors mixed together make orange. So, sine squared x over cosine squared x is equal to tangent squared x. We have verified that the left-hand side is equivalent to the right-hand side.